T3C. In this video, we're going to look at graphing tangent and cotangent, okay? What I want you guys to do, actually at the very beginning, I'm going to have you pause. I want you to fill in this table here, okay, with values for tangent. So just the parent function, okay, if I plug negative pi in for x, what would tangent of negative pi be? All right, and so on your unit circle, remember you memorized all of these. When they say negative pi, they just mean going in the opposite direction. So normally we counted everything this way, counterclockwise. Negative means to go clockwise. So if I go clockwise pi, I'm still at the same spot. Okay, then the next one was negative 3 pi over 4, so normally that would be this way, but we're actually going to go the other direction, so it would be this point right here. Okay, so positive 5 pi over 4 is negative 3 pi over 4. Alright, and then same thing here, negative pi over 2, so pi over 2 is 90 degrees, so I'm going to go 90 degrees this way, so this one would be negative pi over 2. Okay, this would be negative 3 pi over 4. Okay, so see if you can fill in this chart by yourself, and then when you unpause, I'll come back and have it filled in as well, so you can check. Alright, so hopefully you were able to come up with these numbers at least for the positive angles, because you should know how to do those. So, where tangent is undefined, okay, these cause in the graph asymptotes. Alright, so these are asymptotes. Remember an asymptote, and they're vertical asymptotes. So remember, asymptote here would be a vertical line that the graph never touches. So when we graph tangent, all we're going to graph is the space between two asymptotes. So when I graph the parent function, y equals tangent of x, I'm going to graph from this first asymptote at negative pi over 2 to the next one at positive pi over 2. So remember with sine and cosine we had those parent function patterns that we had to memorize. So here is your parent function pattern for tangent. Asymptote, negative 1, 0, 1, asymptote. So let's actually graph this and see what it looks like. Okay, so I graphed those points here from negative pi over 2 to positive pi over 2. This is what it looks like. Just like sine and cosine, this graph is going to repeat. So if I were going to plug in more values, I would have another one of these little shapes and then another asymptote and another one of those shapes, and the same thing going in this direction. I would have one of these and another asymptote. Okay, so the graph repeats. I'm only going to ever make you graph one little section at a time, but you do need to understand that it repeats that little kind of squiggly thing between asymptotes in both directions for forever. Alright, so now let's look at these key characteristics. Amplitude. We don't have a wave shape here. So for tangent, there is no amplitude. Just like when we did sine and cosine, there were no asymptotes. Tangent doesn't have an amplitude because it's not a wave-shaped graph. Alright, period. How far is it from, remember this is the space between asymptotes, so from negative pi over 2 to positive pi over 2. If you were to do pi over 2 minus negative pi over 2, you would get a distance of pi. So the period for tangent is pi. Okay, range, well, this side of the graph goes up forever, and this side of the graph goes down forever. So tangent is all real numbers. Okay, this is symbols for y as an element of the real numbers. If you want to write from negative infinity to positive infinity, that would be fine as well. Because this graph has all real numbers as a range. Okay, this is the parent function, so there is no phase shift, there is no vertical shift, but we'll talk about how to find those when they occur. It's very similar to what we did with sine and cosine. Asymptotes. You're going to list where the asymptotes are. Here's the key thing here. Asymptotes are vertical lines, so you need to write the equation of a vertical line. You cannot just write negative pi over 2. You need to write that x equals negative pi over 2 to show me that this is a line, not just a random number. Alright, so there's an asymptote at x equals negative pi over 2 and an asymptote at x equals pi over 2. And then key points, just like we did with sine and cosine, you're going to write down those points that we plotted. Alright, not the asymptotes. The asymptotes are not key points, they are lines. Alright, but we are going to write down those points. Okay, so graphing tangent, just like with sine and cosine, I am not always going to give you the x values. You're going to have to find them on your own. So, find the first asymptote. Okay, it is bx minus c, still, just like we do with cosine and sine, but this time it is going to be set equal to negative pi over 2, and then you solve for x. Okay, that is because in the parent function of tangent, which we just graphed, the first asymptote is at negative pi over 2. So that's what you're going to set it equal to. Then you're going to find the period. Okay, for sine and cosine, this was 2 pi over b. For tangent, it is going to be pi over b. Alright, because that's what the period for tangent is pi. Alright, then you are going to find the interval, which is still going to be t over 4, period divided by 4, and add that to the first asymptote to get your key points. So what will happen is when you fill out your table every time, you'll put your first key point and that will be an asymptote. Alright, then you will find the next 3 key points. Then you'll have the 5th one, and that will also be an asymptote. And then these 3 in the middle, the pattern for tangent is negative 1, 0, 1. Okay? So that will be what it is every time. There will be an asymptote, and it will be negative 1, 0, 1, and then there will be a second asymptote. Alright, so let's go through an example here, start to finish. Y equals tangent of 2x minus pi over 4. So first thing I'm going to do is find my first asymptote. Alright, and it's going to be bx minus c, which is 2x minus pi over 4. I'm going to set that equal to negative pi over 2. So I add pi over 4 to both sides. 2x equals negative pi over 4. Negative pi over 2 plus pi over 4 would be pi over 4. Alright, and then I divide by 2. And I get x equals negative pi over 8. So my first asymptote is that x equals negative pi over 8. And when I make my table, that is going to go first. Alright, then I need my period and my interval. So the period, remember, is pi over b. Alright, if I look at this number right here is b, so this is pi over 2. So period is pi over 2. The interval then is the period divided by 4. So pi over 2 divided by 4 would give me pi over 8. So that's what I'm going to add over here every time. Negative pi over 8 plus pi over 8 would be 0. Plus pi over 8 is pi over 8. Plus pi over 8 again is pi over 4. Plus pi over 8 again is 3 pi over 8. And that's 1, 2, 3, 4, 5 key points. Okay. Then we're going to use the parent function y values. So the first one is an asymptote. The second one is negative 1, and there is no a or d to change that. So it's going to be negative 1, 0, 1, and then an asymptote just like in the parent function. Okay, so let's go ahead and graph that. Okay, and then key characteristics. Amplitude doesn't apply to tangent. Range is all real numbers. Alright, now phase shift. For sine and cosine, we said that the phase shift was the first key point. Okay, for tangent, that doesn't work. Alright, because the phase shift is actually how far we move from the parent function. So because sine and cosine start at 0, wherever they move to is also how far you move. So if you think about being on a number line, if I go from 0 to 2, I moved 2 spaces. If I go from 0 to 4, I moved 4 spaces. But tangent doesn't start at 0. So I actually need to know, normally it starts at negative pi over 2. We moved it to negative pi over 8. I need to know how far I actually moved that. Okay, so for tangent, your phase shift is going to be c over b. And we're just going to take those numbers straight from the equation. The only thing that gets tricky here is remember that in the standard form, this is bx minus c, which means that this is the opposite. So you have to change the sign here. That's what you have to remember to do, is change the sign. Okay, so I'm going to use positive pi over 4 over b, which is 2. So my phase shift here, pi over 4 over 2, is pi over 8. Okay, my phase shift is pi over 8. Now, this is just coincidence that these ended up to be the same number with a different sign. That's not a rule. That won't work for every single one. So you have to do c over b to find your phase shift. Okay, vertical shift, there's nothing added outside, so that would not apply, or be none, or 0, whatever you want to write there. Okay, and then key points, again, we would copy from the table, so 0, -1, pi over 8, 0, pi over 4, 1. Okay, so that's how you graph tangent. And then for graphing cotangent, here's what I want you to do. I want you to see if you could come up with the parent function graph for y equals cotangent of x. I want you to think about how tangent and cotangent are related. How are they related to each other? Okay, what changes if I want to find tangent versus wanting to find cotangent? And see if you can come up with what you think is the graph y equals cotangent of x. So I want you to bring that with you to class. And then in class we will go over what is different, what is the same, and how to graph tangent versus cotangent.